Hi folks, this is number 8 from the Unit 4 extra review sheet. So here they give us some information not about the angle x, but of the angle 2 times x. So they tell us that the angle 2x is in the third quadrant, so between pi and 3 pi over 2. And they tell us that cosine of 2x is equal to negative 6 over 15. Okay, so let's see what they're asking us to do. So first they're asking it to sketch 2x, so nothing complicated here. We just some angle in the third quadrant. Okay, so put it somewhere there. So there's my angle 2x. Okay, next thing they asked us to do is to determine the quadrant of x. Well, x is half of 2x. Okay, but I don't know exactly where it is in the third quadrant. So if I wanted to determine where x could be, okay, well, let me look at the minimum possible angle it could have in order for it to be in the third quadrant, and the maximum possible angle it could have. So to be in the third quadrant, 2x has to be at least equal to pi. So that means x must be at least pi over 2. Okay, that's the minimum value for x. Okay, at the very most, 2x can be equal to 3 pi over 2. Okay, so that means x at the very most can be equal to 3 pi over 4, divide both sides by 2. Okay, so in fact I can even be more precise than the quadrant of x. I can say that x has to be somewhere between pi over 2 at the very least and 3 pi over 4 at the very most. But if you live between pi over 2 and 3 pi over 4, it means you have to be in the second quadrant. Okay, so x is in the second quadrant. Okay. Now, the last thing they want us to determine is the exact value of cos x, but they give you information about cos 2x. So you have to determine, is there a relationship between cos x and cos 2x? And there is. It's using one of the double angle formulas. So here, because I'm looking for cos x, the double angle formula I'm going to use is cos 2x is equal to 2 cos squared x minus 1. Had I been looking for sine x, I would have used cos 2x equals 1 minus 2 sine squared. Okay, but I know what cos 2x is equal to. It's negative 6 over 15. So the only thing I have left that's variable is this angle x. Okay, and in fact, I only need to find cos x, so I'm going to isolate cos x. Okay, so let's solve. First, before I go any further, let's simplify this here. So divide numerator and denominator by 3, so we've got negative 2 over 5. Okay, so let's add 1. So we got negative 2 over 5 plus 5 over 5. Okay. Okay, so what do we have? Negative 2 plus 5 is 3 over 5. Okay, now let's divide by 2. So that gives us 3 over 10 on the left is equal to cos squared x. And then finally, I can just take the square root of both sides. So cos x is equal to, and don't forget that when you take a square root, you have the option of a positive and negative. Okay? But cosine of an angle can't have two values. Okay? Because cosine's a function. It can only have one value. So this is why they actually were helping us out in part B to determine the quadrant of x. Because this is what's going to now help determine the sign that I'm going to choose. So because x we determined was in the second quadrant, well, cosine is negative in the second quadrant, so I have to choose the negative square root. So here I can say that cos x is equal to the square root of 3, the negative square root of 3 over 10. Okay, so just to recap, okay, they're giving us information about 2x. I was able to determine the range of values that x could have. That allowed me to say that it had to be in the second quadrant. And then here, in order to determine cos x, I just used my double angle identity. Okay, so something we've also done when determining half angles. Okay, that's it for this one.